Hello, so in this video I wanted to talk quickly about two example problems you might see in quadratics. So we've covered quite a bit in quadratics. We've covered the basics, the shape, we've covered standard form, factored form, and in the next few videos I'm going to go into the next little bit of factoring and how we do all that, and maybe even get to transformation. So there's a lot to come, but we've covered a lot as well in the past 3-4 videos. I've been really summarizing everything, and I've been condensing it down to 10-minute videos, so there's quite a lot there for you guys to work through, but I've been trying to summarize everything down to 10-12 minute videos. So I have two questions in front of me that I saw, and these are questions that I've worked through myself in grade 10, and I've seen these questions on tests, and not these exact questions per se, but these are questions that are things you might see on a test, so whenever we're back in school, might have to deal with this in the future or whenever. So I'm going to do two problems, shouldn't be too long, 10-12 minutes possibly, and just two problems to help you out in this quadratics unit. So one problem I saw was a graph, right? So they have a graph that looks something like this. I believe it does look not exactly like this, but it looks something like this. Now I haven't put the exact graph up, but essentially the things you gather from it are you get two of your zeros, and they give you a y-intercept. So the zeros in this case are, so let me just write down the zeros, -4, 0, and 2, 0. So -4, 0, and 2, 0. So put a comma there, and the y-intercept for this graph is, I believe, 0, 4. So, great. So they gave you this information, or they just gave you the graph in general. I just summarized the information. To find the zeros, obviously, there is one 0 here at -4, 0, and there's one 0 here at 2, 0. So you write down your zeros, you write down your y-intercept. Now the question for this is, find the equation for this in factored form. So find an equation. Find factored form. Let's just call it that, alright? So this is a problem that is very common for any quadratics unit. They give you the two zeros, and they give you a y-intercept, and they want you to find it in factored form. And as we know, if you watched my previous video on expanding polynomials, you can go from factored form to standard form quite easily. But finding factored form is our main goal. So how will I find factored form? So, dropping the marker again. For some of you that have been watching my videos, you know I drop markers quite often. Anyways, there is, well, back to what I was doing. So we have zeros, we have y-intercept, we have to find the equation in factored form. So if you remember what factored form was, it was y equals a, so a is my a value, x minus r, x minus s. So that's what factored form is. Without the letters, we know that there's two zeros, right? So let's write a factored form equation for this. So I don't know my a value for this, right? There's nothing that gives me my a value. I'm going to have to solve for my a value. But I do know my zeros. So x, so be careful here. So my zeros are -4, 0, and 2, 0. And if you remember, the key thing I told you is you flip the signs when you're going from factored form to zeros and zeros to factored form. So instead of writing x minus 4 as one of my zeros, I'm going to write x plus 4. Right? Because when I'm going from zeros to the factor in here, to the expression in here, I switch the sign, right? So x plus 4, one of my zeros is x minus 4, right? You just switch the sign when you're writing the zeros. So x minus 4 becomes -4 becomes +4 in the expression. And what's my other zero? 2, 0, right? So I write x minus 2. Because, again, I switch the sign, right? So if I have zeros, my zeros are -4 and 0, 2 and 0, then my factors here are going to be x plus 4 and x minus 2, instead of being x minus 4 and x plus 2. You just switch it. So if you had this given to you and you wanted to find the zeros, then you just switch the sign, -4, 0, and you switch the sign, 2, 0. Again, quick side note, don't need to worry about that right now. But here, I have this so far. So I have y equals a, x plus 4, x minus 2. So all I'm missing now is my a value. Well, how do I get my a value? Well, if you notice something, I'm just going to get rid of that, nothing too important there. If you notice, I've been given a y-intercept. Well, they didn't just give us a y-intercept for no reason, right? They gave it to us for a reason. So why they gave us the y-intercept is because I can plug in my y-intercept and I can find the a value. So how I do that is actually pretty simple. If you've done linear equations, linear systems, you did y equals mx plus b and you subbed in points to find the slope. Same sort of idea goes here. So I plug in 0, 4. So wherever I see y and x, I plug in the coordinates. So 4 is my y coordinate. So 4 is y. So a I don't know, I'm solving for. And 0 plus 4, right, because x is 0. 0 plus 4 and 0 minus 2. Simple, right? 0 plus 4, 0 minus 2. So now let's go ahead. So 0 plus 4 is 4, right? 0 minus 2 is negative 2. So 4 is still on this side. I multiply a by whatever I get here. So what's 4 times negative 2? Negative 8. So it's negative 8a, right? So I multiplied 4 by negative 2, which was negative 8, and then I multiplied negative 8 by a, so negative 8a. So what am I solving for? I'm solving for a, right? So how do I solve for a? Let's divide both sides by negative 8. So I get negative 4 over 8 equals a. I just divided 4 by negative 8, and it's negative 4 over 8. So I can write that as a simplified fraction. 4 over 8 can be written as half, exactly. So a equals negative half, right? Because I just simplified that fraction down, and I found my a value. So now that I have my a value, I can rewrite it in factored form properly with an a value now. So my final equation would be y equals negative half, right? Because that's my a value that I found, right? Right here, my a value that I found. Negative half equals x plus 4, not equals, x plus 4 and x minus 2. There we go. That would be my answer. Again, how did I work through this problem? I had my zeros, I had my y-intercept, so it's always just to write those down. Then I put it in factored form, right? So factored form is taking the zeros and writing it as two expressions. So I wrote x plus 4 because my 0 was negative 4, 0. Remember, I switched the sign, x plus 4. And then I wrote x minus 2 because 2, 0 was my 0, so I wrote x minus 2. So there were my two zeros, but I did not know what my a value was. So how did I get my a value? Well, I plugged in my y-intercept. And what do I mean by plugging it in? I took my y, put it in for y, and I took my 0, my x coordinate, and I put it in for my x coordinate, which was x here. So 0 plus 4, 0 minus 2. So after all that, I did the math with a, like I tried solving for a, and when I solved for a, I found out that a was negative half. Exactly. So I took the a value, I wrote it as such. So that's simply how you would do a question like this. One step further, if it wanted you, it might even want you to go all the way and write this in standard form. I'm not going to do that now, but all you would do is multiply your two binomials here, bring the negative half in. If you've watched my expanding polynomials video, you would know exactly what to do here. So if you're watching the videos, you should be good to go ahead. So hopefully this question makes a little bit of sense. I know I went fast, but hopefully this is making a little bit of sense and you're being able to solve a few of these problems. I'm going to do one more problem that I noticed. This one's going to be much shorter though. So let's say they gave you an equation such as y equals negative 3, x minus 1, x plus 5. Right? So they gave you an equation like that, and they asked you, what's the vertex? This is a very common question you're going to run into any quadratics unit. This is supposed to be very basic. So what's the vertex? Well, how do I find the vertex? Well, it's always good to draw a sketch like this. So negative a value, so I know it's going to look something like this, right? So again, something like that. So my two zeros are given to me, right? This is factored form, right? I can identify its factored form because I see two brackets, right? Two brackets means factored form. So what are my zeros? Well, let's write down the zeros first of all. Again, be careful when you're going from factored form to your zeros. If it's negative 1 here, then my 0 is going to be 1, 0. And if it's positive 5 here, my other 0 is going to be negative 5, 0, right? Those are my zeros, 1, 0, and negative 5, 0. Does it make sense? Yes, I switched the sign, brought it here, switched the sign, brought it here. So negative 5, 0, 1, 0. So I need to find the vertex. So again, here are my two zeros. I need to find this point here, the vertex there. These aren't the exact, this is an exact graph, but gets the idea down. So I need to find the vertex. So first of all, we're going to find our axis of symmetry, the line that cuts the graph in half, right? The axis of symmetry. And if you remember how to find the axis of symmetry, you find two respective points on the sides of the graphs that are the exact same. Well, not the same, but they are the same on each side. So the zeros are both on the x-axis, right? And they are on the two respective sides of the parabola. So I can use this. So I need to find the midpoint of these 2 points, right? I need to find the middle of these 2 points so I can cut it in half, right? So to find the middle, all I do is I take the average. So I add the 2 zeros and I divide by 2. So I add, so you might see it written as this. The x-sim, or the axis of symmetry, is equal to -5 plus 1 divided by 2, right? That's all there is to it. So that's -4 over 2 equals -2. So now I'm actually going to change this graph a little bit. It's pretty bad in that case. So actually 1, 0 is somewhat like here, -5, 0 is there, so y and x. Again, so what did I do here? I added my 2 zeros, -5 plus 1, divided it by 2, because I'm trying to find that point there that I cut it in half, right? I'm trying to find that point there. So to get that, I added the two x's together, divided by 2, and I got -2. So now that I know my x-sim, my axis of symmetry, I know my x-coordinate for the vertex, right? So I'm going to write that in blue, because I like writing my answers in blue. So I know the x-coordinate for my vertex now, because I found the axis of symmetry. All I need to do is get my y-coordinate. So to get my y-coordinate, I just plug in my x-coordinate. It's that simple. So let's do y equals -3. So what's the x-coordinate I'm plugging in? -2. So -2 minus 1, right? I'm just plugging it into the equation they already gave me. And -2 plus 5. There we go. So let's solve it now. -2 minus 1 is -3. -2 plus 5 is 3, right? -3. -2 minus 1 is -3. -2 plus 5 is 3. So -3 times -3 is 9. Times 3 is 27. So now I know my y-coordinate for my vertex, which is 27. So my vertex is at -2, 27. So vertex up here. So how did I solve this problem? Quick summary. All I did was I took my 2 zeros, I identified them because I got a graph, right? I mean, I got an equation and they told me what the vertex was, so I made a quick sketch here. So 1, 0 was one of my zeros and -5, 0 was the other zero. I added the zeros together because I want my x-axis, or I want my axis of symmetry, sorry about that. So for the axis of symmetry, I just added my zeros, divided by 2 because I want the middle. And I got -2. So -2 was my axis of symmetry, which is the x-coordinate for the vertex. That's my axis of symmetry. And I plugged in the -2 into my equation, and I got y equals 27. So my vertex was -2, 27. So this graph, I apologize for me messing up the graph a little bit there, but that's how essentially it would look like. I'm going to try and put up a graph of this, so you might get a general idea of that. Hopefully I can put that in, but if I don't get that in, that's okay, because on a test, you're probably not going to get the graph, you're probably just going to get the equation, and you're going to be asked what's the vertex. So you would find the zeros, you would find your axis of symmetry. When you have the axis of symmetry, plug it into the equation, get your y-coordinate, and you have your vertex. So those were the 2 problems I wanted to do today. Hopefully those 2 problems gave you a better understanding of quadratics. So again, I'm going to move into some deeper subjects such as factoring and things like that in the future videos. Hopefully this helped. Again, keep watching the videos. Hopefully you're understanding quadratics. And again, I'm really condensing everything down into 10-minute videos. So these are very rushed, as in I'm going pretty fast. It's not a lecture. It's not supposed to be a lecture. It's supposed to be supplementary. So hopefully these are helping still somewhat. And keep watching for more videos. Thank you.